Algebra 2 students, this is a video just explaining and going through the combinatoric summative practice that you received in class today. So you just have your worksheet handy, and I'll go through how to complete each of these. So number one, we've got a basketball team that has 6 guards, 8 forwards, and 2 centers on that roster. We want to select 2 guards, 2 forwards, and 1 center to start the game. So again, we think, does order matter? No, it doesn't, because the guards could be Bill and Jeff and Bill. It's the same team. It's the same 2 guards. Okay, so order does not matter. You obviously cannot have repeats. You can't have the same player play both guard positions. So this is combination. To get the guards, it would be 6 choose 2. And we need the 2 forwards. We have 8 forwards. We're going to choose 2 of them. And we have 2 centers. We're going to choose 1 of those. The and means we're going to multiply. 6 choose 2 is 15. 8 choose 2, I believe, is 28. And 2 choose 1 is 2. So you would multiply those together to get your answer there. Number 2, now it's talking about a specific guard, a point guard, a shooting guard, a small forward, and a power forward, and a center to start the game. So now it does matter what order you pick them in, because you might have Billy playing the point guard and Jeff playing the shooting guard, or Jeff the point guard and Billy the shooting guard, and that would be different. So order does matter. There is not repetition. So now it's the same type of setup, but it's permutation. Permutation 6 choose 2 times permutation 8 choose 2 times permutation 2 choose 1. We could also do it by how many choices do I have for the point guard? I would have 6 choices for that person. The shooting guard, then I would have 5. That's what permutation 6 choose 2 equals. And then I'd have 8 choices for my small forward, 7 for my power forward, and 2 for my center, and I would multiply those together. Number 3, we are putting signal flags up. We've got 10 flags. Some are red, some are blue, some are yellow. Order is going to make a difference because it's the sequence that denotes the message. So it might be red, red, yellow, yellow, blue, blue, red, yellow, yellow, and yellow. It would be one option. So this is permutation. Order is important. There is repetition. So therefore, we've got 10 letters, and we have repeats. We've got 3 R's, we've got 2 blues, and we've got 5 yellows. So 10 factorial divided by 3 factorial, divided by 2 factorial, divided by 5 factorial. Number 4, we're talking about 2 groups and some that are interested in both. So our formula here, you got the number that are going to be in math or athletics will equal the number in math plus the number in athletics minus the number in both. So setting this up, we've got 400 total students. 168 of them are in math. 100 of them are in athletics. 67 are in both, so we're going to subtract that. I've got 268 minus 67 is 201. So 201 are in either math or athletics, which means the other 199, because there's 400 total, would be in neither activity. Number 5, we're going to have 13 people in the cafeteria. We're going to line them up. 8 boys and 5 girls. It's going to be girl, boy, boy, girl, boy, boy, girl, boy, boy, and so on. So therefore, we've got to put those 8 in order, the 8 boys, which I could do, that's permutation. 8 choose 8, which is the same as 8 factorial. I'm going to put the 5 girls in order. 5 choose 5, which is 5 factorial. And I'm doing both of them. It's and, so I'm multiplying them together. It would be the same as if you have 13 positions. And your first person is a girl. You have 5 choices for that. And then you have a boy. You'd have 8 choices. The second boy would be 7. The second girl would be 4. The third boy, you'd have 6 choices, then 5. The next girl would be 3. And we would multiply all these together, going all the way down. So you would end up with and those would be multiplied together. Number 6, we got 6 teams. We want to know how many games will have to be played. So does order matter? No, because if Springfield plays Sleepy Eye, then Sleepy Eye doesn't have to play Springfield. The order does not matter. I just need 2 of those teams, and they cannot repeat. Order's not important. You don't have repetition. This is combination, and it'd be combination 6 choose 2, which is 15. So there'd be 15 total games that need to be played. If we want them to play each other twice, then we just got to have double the number of games. So we'd have 30 games then. Number 7, we're going to form an outfit. We got a shirt, we need a vest, we need a tie. We have 3 choices for that shirt. We've got 2 for the vest, we got 4 for the tie, and we're going to multiply them together, which would be 24. Order not really important. No repetition, so it's combination 3 choose 1, 2 choose 1, and 4 choose 1, and then multiplying them all together. Number 8, I got a bookshelf. Has space for 5 books. If 14 different books are available, how many different ways can one select the 5 books to put on the shelf? So we're not actually putting them on the shelf. So again, we have 14 books. We're just choosing the 5. Order does not matter, and there's no repetition, so it'd be combination 14 choose 5. If I'm actually putting them in order, arranging them, then it'd be permutation 14 choose 5. Number 9, we're doing a password. Order's important. I need 2 letters and followed by 3 digits. If repetition is allowed, that means I've got 26 choices for the first letter, 26 for the second, and then 10 choices for each of these digits because they can be repeated, and they should be multiplied together. If repetition is not allowed, now 26 for the first letter, only 25 choices for the second one, and then 10 times 9 times 8 times 7. On the back, we've got permutations of the word Sleepy Eye. Order is important, obviously. It's a permutation. There are repeats, so number 10 would be 9 factorial because there's 9 letters. We're going to divide by 4 factorial. There's 4 E's, and 2 factorial because there's 2 Y's. Number 11, 6 letters, no repeats, so it's just simply 6 factorial. Number 12, we've got 6 people sitting around a circular table. If they're sitting in a straight line, it would be 6 factorial. If it's in a circle, we have to base it on 1 position. So it's 1 less, and that would be 5 factorial. 13, if I'm going to go from A to Z, I have to go either east or south. I need to go east 8 times and south 3 in any order. Okay, so order is important here. That would be one option. You could go south, 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 and then a whole bunch of easts until you're in the corner. But this is a permutation with repetition. So we have 11 total letters. I've got 8 E's and 3 S's. So 11 factorial divided by 8 factorial divided by 3 factorial. 14, I've got to go from A to Y and from Y to Z. So going from A to Y, I've got to go east 3 times and south twice. I've got 5 blocks to do, and I've got 3 repeats and 2 repeats. And then from Y to Z, I've got to go east 5 times and south once, 6 blocks, and I've got 5 repeats there. And I would multiply them together because it's and. Hope this helps some of you that missed the class or the review class. If you've got questions, like always, feel free to come on and get some help. Thanks.